So now we want to consider confidence intervals for the population proportion. So we want to be able to estimate proportions or percents. So for example, we could ask what proportion of people approve of the president's job? So job approval ratings are percentages. What is the percent effectiveness of a new vaccine against a viral infection? So again, there's a percent and proportion, and those are your keywords that are telling you that you want to do a proportion and not a mean. So if you see the word mean, then you know you're doing confidence interval for the mean. So to estimate proportions, we need to form a new sampling distribution, and it's the sampling distribution of the sample proportion, which we'll write as P prime. So the way that you do this is you take repeated samples here of the same size from your population, and then you compute the proportion of successes. So whatever outcome you're interested in. This is a binomial experiment. And your P prime is x divided by n, so it's successes out of total. And then you compute the probability distribution of the sample proportions that you find from repeated samples. So you make a histogram of the percentages of successes. And this gives us a new probability distribution called the sampling distribution of the sample proportion, which we are denoting P prime. So what are the properties of this new sampling distribution? Well, the sampling distribution of P prime is going to be approximately normal if n is big enough and if your population proportion is not close to 0 or close to 1. And the way we measure that is by looking at n times P prime. So that's the number of successes, and n times 1 minus P prime, that's the number of failures, and both of those need to be greater than or equal 5, and that'll ensure that this distribution is approximately normal. And then that way we can use normal CDF and inverse norm to compute probabilities. Also, the mean of that sampling distribution, the P prime distribution, is P, the population proportion. And then the standard deviation of that sampling distribution is the square root of P 1 minus P over N. So with this in mind, the way that we compute our confidence interval for the proportion is like this. So this is a 1 minus alpha 100% confidence interval for the proportion P. So you take your point estimate plus or minus a z-value times standard deviation. Well, that's what we did before. Before with means, we took x bar plus or minus your z-value, z alpha over 2 for large samples when sigma was known, times sigma over root n. So this was the sampling distribution of the standard deviation of the sampling distribution for x bar. That was sigma x bar. Well, we're doing the same thing here. Point estimate plus or minus z-value times a standard deviation. It's just that now our point estimate is sample proportion, and our standard deviation is this guy here instead of sigma over root n. So that'll be P prime plus or minus z alpha over 2 times root P prime 1 minus P prime over n. And we're using the sample proportion P prime here instead of the population proportion P because we don't know P. So we have to use our best estimate. So confidence interval requirements: in order to compute this confidence interval, you need to have a randomly selected sample from the population of interest, and then the sampling distribution has to be normal. So np prime has to be greater than or equal 5, and n1 minus p prime greater than or equal 5. And that's this condition up here. So property of the sampling distribution, that makes it approximately normal. So this is the normality check here. So let's check conditions here for an example. So in a survey of 1,124 randomly selected American taxpayers, they were asked, hey, do you think you're paying too much in income taxes this year? And of those 1,124, 315 answered, yes, I'm definitely paying too much. Are the requirements for the confidence interval satisfied? So first requirement, is it a randomly selected sample? Well, 1124 randomly selected American taxpayers. And then we're going to make a conclusion about about American taxpayers. So it's from the target population. So random is given. So that one checks out. Second condition, we've got to compute that p prime and then n p prime and then 1 minus p prime. So our p prime here is going to be success for us as a yes answer. So 315 yeses out of 1124. We'll compute that. So 315 divided by 1124, 0.2802. We'll take 3 decimal places. 0.280. So now n times p prime is going to be the 1124 times our 0.280, which is the 315 over 1124. This should give us 315. So 1124 times our 0.280, 314.72, and that's just because we rounded. So this is approximately 315, and that's definitely greater than or equal to 5. And then we do n times 1 minus p prime. So that's going to be our 1124 times 1 minus the 0.280. And let's compute that one. So 1124, and then we need some parentheses. 1 minus 0.280, close it up. 809.28, so approximately 809. So this is 809.28, definitely greater than or equal 5. So that checks. So yes, the confidence interval conditions are satisfied, both of them. So now we know that we can actually compute a confidence interval and have it be valid.